This is FizzBuzz. FizzBuzz is a popular coding challenge which is often used in interviews to test whether one knows how to program. Has anyone seen FizzBuzz before? Almost everyone. Has anyone implemented it before? Okay, I hope you got the job. This is an implementation in JavaScript. For those who aren't familiar with it, the task is to print the numbers 1 to 100 to the console. However, if the number is divisible by 3, print the word fizz instead of the number. If it's divisible by 5, print the word buzz. If it's divisible by both 3 and 5, print FizzBuzz, hence the name. So this is kind of what it looks like. There's different ways to implement it. Does anyone notice anything wrong with this implementation? Yeah, I know what you're thinking, and that's right. It's not flexible enough. For example, what if instead of wanting to log the results of the console, you wanted to write it to a file or stream it to some log storage system? What if instead of printing fizz on the number 3, you wanted to print fizz on the number 4? What if you wanted to customize the way that two integers are compared for equality? Well, luckily, some very smart people have thought of these problems and solved them. With this FizzBuzz Enterprise Edition, this is a completely enterprise-ready, modular, and extensible version of FizzBuzz. It's spread over 128 files. The entry point of the application looks like this. You might look at this and think, I don't see the logic for FizzBuzz in there, and that's the point. The logic is extensible and pluggable. This is enterprise software. For example, if you wanted to change the number 3 for number 4 and print fizz for the number 4, you simply need to change this constant, which is then passed to the fizz strategy, instantiated by the fizz strategy factory, and it will operate in exactly the way you want. Now, FizzBuzz Enterprise Edition is, thankfully, a joke. But it works as a joke because it's actually quite close to the truth. Has anyone worked in enterprise software? Okay, so you've probably seen something. In fact, it probably looks just like the app that you were working on, right? And the reason why it's very close to the truth is because as software developers, we're all smart, right? And smart people like to build things, and we not only like to build them, we like to build them in clever ways. And this is a natural tendency, probably a lot of us have. And it leads to a phenomenon known as over-engineering. This is building things much more complicated than they're actually needed for the task at hand. Luckily, there is a principle that can counteract this tendency to over-engineering. It's called "you aren't going to need it," abbreviated to YAGNI. You aren't going to need it is like a rule of thumb. It's something that you can follow when you're thinking about how to design things. And it says, don't implement something, don't implement functionality until it becomes apparent that you actually need it. A lot of smart people would support this and advise it as well. So, for example, John Carmack, he's a legend of our industry, one of the co-creators of Doom, a prolific programmer. He says it's hard for less experienced developers to appreciate how rarely architecting for future requirements turns out to be net positive. In other words, as a developer, you try and predict what hypothetically might be needed by your application in the future, and you often get it wrong and end up overcomplicating things. So, my talk today is about you aren't going to need it. My name, I didn't introduce myself. Ramon did a good job before, but my name is Michael. I'm originally from England. I've been living here in Vienna for the past 10 years. I've been writing software for maybe 20 years. And today I want to talk to you about some thoughts I have about software design. So my talk is, you aren't going to need it. Or are you? Let me start off with a story. About 5 years ago, I started writing an open source e-commerce framework. And as I started off, I had to think about APIs and how to design things. Now, in these kind of applications, you have lots of lists of things. You have lists of customers, orders, products, and so on. And lots of these lists get kind of big. You might have hundreds of products, or thousands, or hundreds of thousands of products. Hopefully, you have lots of orders and lots of customers eventually. So to represent these lists, you'd often use pagination, so that you, instead of getting the whole list at once, you can get, say, the first 10, and then you can request the next 10, and so on. It makes the user interface much easier to navigate. It means you don't have to download all the data every single time. Pagination, I'm sure you're all familiar with it. In this application, we also have other lists of things which they're not so big. So, for example, we have product variants. You see t-shirts here, so the product could be a t-shirt, and the variant could be small, medium, large. 3 variants, extra large, 4, or extra, extra large. 5 variants, not so many. We probably don't need to paginate this. You're not going to need it. Yagni, after all. We also have this feature called facets, which are like tags. You can tag products with like the brand or the material that it's made of and so on. So, you know, how many facets are people going to actually want? 5, 6? There's no point paginating this kind of stuff. Yagni, you're not going to need it. We have this feature called customer groups, where you can split your customers into different groups. You can say, these customers are members of our discount club, so they get a discount. These customers are business customers, so we don't charge VAT. You're not going to need many customer groups, right? 2 or 3, maybe 4 maximum. Don't paginate this. Yagni. We also have this feature called channels, which allows you to split your whole store by sales channel. Website, the physical store, maybe Amazon, you want to sell some on Amazon, that's in a channel. Now this is really a niche feature. Not many people even need it at all. Those who do need it, they need a few channels, right? You don't need to paginate this. Yagni. So this was 5 years ago. In that time, like, people started to use it. Lots of developers, thousands of developers use it. It's used by big enterprises that you've heard of, big startups, supermarkets, and all sorts of projects. It's open source, right? So people start to open issues on GitHub. This is what I spend most of my time doing, reading these issues. Anyway, they started to roll in. First of all, it turned out that actually, maybe we do need to paginate variants. Not everyone is just selling t-shirts with like 5 different sizes. Some companies are selling industrial piping with many different diameters, building materials, and lengths, which overall gives like 500 or 1,000 variants. Okay, I messed that one up. I got it wrong. Fair enough. Suddenly this guy comes along and he's like, oh yeah, you know those customer groups? We actually use 3,000 of them. The user interface is really slow now. What? Someone else is opening an issue. Oh yeah, facet values, great. We have between 2,000 and 3,000 of them. Okay. Channels. This project is using 1,600 channels. Wait a minute, something's not right here. I was following a principle that was taught to me by very clever people. What went wrong? Speaking of very clever people, who's this guy? That's right, Sir Isaac Newton, famous for inventing gravity, calculus, or co-inventing calculus, and he came up with these laws of motion, right? You've probably heard some of these. The third law of motion states that for every action, there is an equal and opposite reaction. I propose that there's a similar law for these best practices in software development. For every best practice, there is an equal and opposite best practice. So, on the one hand, we have Yagni, but on the other hand, we have Pagni. Now, I know what you're thinking. What's Pagni? Pagni is probably are going to need it. This comes from a blog post by Simon Williamson, a much wiser person than me. And he's talking about those times when actually you should ignore the Yagni rule. The Yagni rule is good, but there are actually times when the cost of implementing something later is so great and the cost of implementing it now is relatively small, you might as well do it. You should probably do it. He gives some examples, and actually Leo mentioned a couple of these in his talk, in one of his slides towards the end. Timestamps, versioning, he mentioned. And what does Simon Williamson give as a prime example of a PAGNI? API pagination. Never build an API endpoint that isn't paginated. Anytime you think, there will never be enough items in this list for it to be worth pagination, one of your users will prove you wrong. And that happened to me. So, what's going on here? We have some people saying this and some people saying this that seem to be in conflict. This happens all the time in programming, right? Object-oriented, functional, types, dynamic. What else? TDD, test-driven development versus, actually, I just want to build my app, please. Don't repeat yourself, dry, versus, actually, duplication is better than choosing the wrong abstraction. All these things are in conflict. Monoliths versus microservices. One must be the right way to do it, right? The world will try and teach you that things must be in opposition. Thought leaders on LinkedIn and Twitter, X, will try and pit you against one another into conflict. But I'm here to tell you that there doesn't have to be this conflict. You can see things another way. Yagni and Pagni are complementary parts of a whole. There's the same underlying truth behind both of them, and we need some way to find it. And it all comes down to one concept. Judgment. Anyone have kids here? Okay, so, one of your jobs as a parent is like to tell the kids what to do, right? Usually what not to do, actually. Don't touch the hot stove. You can tell a kid to don't touch a hot stove, and they will intellectually, they should understand what you actually mean. Okay, I'm not supposed to touch a hot stove. But then again, it's just another thing that they're not supposed to do. Don't put your shoes there. Don't leave that on the couch. Don't touch a hot stove. So they don't yet have judgment about the relative importance of what I've just told them until they touch a hot stove. And then they will start to develop judgment. The hot stove rule is actually more important than the shoes not being left there rule. This is judgment. You don't have to have pain to develop judgment, but it does help. But judgment is not something that can really be taught. It's a function of experience. I'm going to try and illustrate this with a story about the typical development of the career of a developer as they start off as a complete noob. By the way, these are actual brain scans. Managed to find them. So you start off like complete noob. You got no idea why anything works that way. It takes you hours to get something to work. When it does work, you don't know why it works now, whereas it didn't work before. You literally spend hours, you waste hours of your life because like the two parentheses didn't match. You had an extra one here. You're completely uncertain of everything. There's only one thing you're certain of, which is that undefined is not a function. But you've got to keep going. Eventually, you get into a state where, okay, you've got this narrow set of guardrails in which you can get things done. You kind of, when you're doing this narrow set of tasks which you've really learned, you're okay. If you stray out of them, you plunge into confusion again. At this point, you can probably hold down a junior job, but you're always afraid of being found out. But keep going. You will develop into an intermediate programmer. By this point, you know what you're doing. You can get things done. You run into problems, and you can usually solve those. You can usually figure out some way to get the thing to build and run. You kind of know that it's maybe not the best way, but at least it works. You can ship things. It feels good. Keep going. Now, this is probably the stage where you discover principles like YAGNI, like test-driven development, design patterns. Don't repeat yourself. You maybe start to read all those books you're supposed to read, clean code, and on and on. And now you're getting good. Your code probably looks good. You've learned these principles, these rules of thumb approaches, methodologies. You might not yet have a deep understanding of them, but you know that if you apply certain of these rules, things seem to go better, so it's good. It can happen that you have this kind of niggling feeling in the back of your mind that I'm doing okay, but I don't have a deep understanding. I've seen these other people, these seasoned developers, they seem like they know how compilers work and stuff, and they understand these things. So this awareness of the shallow understanding can then sometimes lead to a defensiveness where you feel like you've got to assert your knowledge in every given opportunity. You've got to be careful here because you can turn into one of those annoying meetup question people who always got to ask questions at the end of the talk just to show that they know more than the speaker. We all go through it, it's okay. Sometimes you can pick up on one of these particular things like test-driven development, and you can just run with it and you say, I'm the TDD guy now, that's my personality. I will not work on a code base. If it's not got 100% code coverage, delete the repo. Or you see it happen with functional programming guys. I'm going to offend people now. I'm going to use array.reduce for everything. My whole app is going to be just a series of reduce functions just composed together. There's going to be 0 variable declarations in my entire app. Otherwise, delete the repo. We go through this. We go through these things as well. I was so into testing at one point. I was testing all my front end components. I waste so many days of my life testing front end components that just change the next time we touch the code base. It just changes. I don't test them anymore. You can also become a trends guy, a cutting edge guy. If you spend too much time on Twitter and stuff, it's really easy to fall into that. At my last company, about 6 years ago, I gave a talk for all the developers in the company, and it was entitled The Future of Front-End Development. Such a grandiose title. I was going to reveal the future. It was basically stuff that I'd read on Twitter. It was everyone's going to be using immutable data structures. Everyone's going to be blah, 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 blah. Just a list of basically fads and trends. But until you've been through at least one cycle of fads, you don't know that they're all fads. You don't know that things repeat. We all go, you've got to go through this process. It's all part of a process, and it's okay. Everyone does it. Anyway, if you stick at it, you come out the other side like a reformed zealot. You realize there is no silver bullet. There's not only one way of doing things. In the past, you might have scolded some idiot for not understanding the way to do things properly. But later on, you might realize that that person who you thought was an idiot just had different constraints. They had different contexts. They had, a different set of skills on the development team, a different timeline, different budget, or whatever. You're starting to develop a bit of judgment now. Okay, keep going and you'll reach the last level. At this point, you know when to use YAGNI and when to use PAGNI. At this point, you could maybe be considered a systems thinker, if we want to say it in a fancy-sounding way. You realize that building software is not about choosing the coolest language with the best micro benchmarks or making the most elegant structures, data structures, and whatever in your app. It's just a tool. It's just a tool to get a job done. Usually it's it just serves a business. It's very boring. It just serves a business goal, right? Most of us are doing this for a job, we're writing apps because there's a business goal. The business has users. The users have certain abilities, expectations, motivations, and these are all part of the way that you design software. So once you get to this point, I think you've developed a sense of judgment, hopefully. You've probably been through painful experiences like touching the metaphorical stove. For me, the pagination thing was like touching the stove, right? Because it was hard to fix. There's so many breaking changes, I had to do a new major version for that. So that was one of my stove touching moments. And the state that you reach can be summed up in two famous words. As you will hear, all senior engineers and architects and people who think they are like that level, they say it depends. Should we use a monolith or microservice? It depends. Should we use types? You should use types. But really, these simple words do encompass like a depth of understanding. If you really kind of reach this point after touching many stoves, you realize that, yeah, actually it does depend. So, to summarize, there are many approaches to building things. Many of them seem opposed to one another and seem to be in conflict. But we don't have to see it that way. We can see them as complementary parts of a whole. And being able to view it that way and really appreciate it depends on building judgment, which is a function of your experience, and also if you go through some painful moments, that will help kind of stamp it in there so you don't forget. And if all else fails, it depends. Thank you very much.